Virtual Mitchell here, looking at 6.2 notes day 2. We're going to start off by looking at some properties of logs. And first one, just remember logs, the log function is the inverse of the exponential function. So if log base b of x equals y, that means that b to the y has to equal x. Going along those same lines, these are inverse functions, exponential functions and log functions. So if we have an exponential function here, b to the log base b of x, if we have the same base here, these two bases are both the same, essentially these are canceling each other out. They're inverses, they're opposites, so we're left with x. It would be kind of the same as having the square root of x and squaring it. They're inverses, those two things cancel each other out. The next two deal with expanding logs. Log base b of x times y can be split up into two logs, log base b of x plus log base b of y. And this kind of goes along with exponential functions. Remember, if you take two exponential functions like x to the 5th times x cubed, the bases are the same. When we multiply, we add the exponents. So we would get x to the 8th for this one. Right, in multiplication we add the exponents. Here, multiplication we can add the logs. On this one, when we divide within the log, we can split this up using subtraction. Log base b of x minus log base b of y. Similarly, this kind of connects with exponential functions. If we had x to the 5th divided by x squared, when we divide two powers of the same base, we subtract their exponents. Division, subtraction. We get x cubed. Our last property here, if we have log base b of x to the m, this exponent can be brought out in front of the log. We get m times log base b of x. So these are some of the properties that you've used before, and they're going to be a little helpful with what we're doing today, which is called logarithmic differentiation. And these are problems that can't be done other ways, or we can use this for other ones that can be done other ways, but this makes it a little bit shorter. So an example of when we would use logarithmic differentiation is y equals x to the x squared minus 3x. That exponent is pretty ugly. If we had something like this, y equals x to the 5th, that'd be easy to take the derivative of. Right? If there was a constant there, we can just use the power rule. We would get 5x to the 4th. Bring that out in front, subtract by 1. We can't do that when we have an expression there in terms of x. So we have to try something different, and we're going to use some of these properties of logs to do that. I've broken down this process into 4 steps. First one is to take the natural log of both sides. So in our example here, we're just going to take the natural log of both sides. We get natural log of y equals natural log of x to the x squared minus 3x. So as long as we're doing the same thing to both sides, we're okay. So natural log of both sides, we're not changing the equality. It's still equal, it just looks a little different. Next step, simplify using the property of logs. So what we just talked about up above is that if we have an exponent here, we can bring that out in front. So we're going to rewrite this. So we have natural log of y equals, bring that exponent out in front, we get x squared minus 3x times natural log of x. Our next step is to differentiate implicitly. Right? We can't solve this for y necessarily all the time. So just take the derivative of both sides as it is. So on the left side, if it's already solved for y like this one was, we're going to get the same thing every time. Derivative of natural log of y, remember we're doing this in terms of x, our derivative would be 1 over y, but we have to multiply it by dy dx, because we're doing this in terms of x, and our variable here is y. On the right side, in this case, we're going to use the product rule because we're multiplying x squared minus 3x times natural log of x. So derivative of the first part, we have 2x minus 3 times natural log of x plus, we have our regular first function times the derivative of the second one. So derivative of natural log of x, we just get 1 over x. I'm going to go ahead and distribute this 1 over x over here. Leave this the same. So x squared times 1 over x, we're just left with x. 3x over x, so we're left with 3, so minus 3. Now, we're trying to find dy dx, find the derivative. We don't want this y over here. We can get rid of that. In our last step, multiply both sides by y. So if we multiply by y, that's going to cancel out. We're multiplying that whole side by y. So make sure you're not just multiplying the 3. That whole right side of the equation gets multiplied by y. If we can help it, we'd like to have our dy dx in terms of just x. So this y right here can be replaced with the actual function of y that's up here. So if we finish this off, we have 2, there shouldn't be a parenthesis there. That should be right there. For this one then, we have 2x minus 3 times natural log of x plus x minus 3. I'm going to put a bracket around that whole thing. That's being multiplied by y, which is x to the x squared minus 3x. Now, if you leave it with just the y in there, you're not going to count it wrong. But remember, in multiple choice question on the AP test, you're probably not going to see it that way. You're going to see it with the actual function in that place.